Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 32. Doing real GMAT problems is one of the best ways to make test day feel more familiar, so let's talk through a few examples together. The problems that we're going to go through today are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to talk through today. The official guide contains retired questions that have appeared on past GMAT exams, so these are going to be quite similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you would like, and then I'll discuss my thoughts on what to take away from each question. I recommend pausing after I read through each one and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute every step in your head if you're on the go, but just do your best. It's a great mental workout either way. If you are in a situation where you can physically write down what you would on test day, that's ideal. This is problem number 140. The problem says, in a weightlifting competition, the total weight of Joe's two lifts was 750 pounds, 750. If twice the weight of his first lift was 300 pounds more than the weight of his second lift, what was the weight in pounds of his first lift? I'll read that again. In a weightlifting competition, the total weight of Joe's two lifts was 750 pounds. If twice the weight of his first lift was 300 pounds more than the weight of his second lift, what was the weight in pounds of his first lift? Option A is 225. Option B, 275. Option C, 325. Option D, 350. Option E, 400. I recommend pausing here and trying the problem out. I'm just going to jump into my commentary. Great warm-up problem, since if you're solid with your translation and algebra skills, you're very likely to get it right. But also a good challenge if you are just starting your prep and you're building up your approach to algebraic translation and solving equations. I also like it because it's a good example of the value of an equation solving technique called elimination rather than the more common substitution method. So let's talk through how that might go. First, as you've probably heard me say quite a bit, it's a good idea to build the habit of writing what's given and asked 100% of the time in the quant section. So that's where I would begin here. We're asked for the weight of his first lift. So I would probably make a variable for that and write something like F equals first lift. We've also talked a lot about writing what variables represent and also using variables that represent actual things in the problem. So here I'm using F instead of X or Y to represent the first lift. So it's a little bit less likely that I'm going to get confused later on in the problem after doing a bunch of steps. And perhaps obviously I'm also taking the time to write out F equals first lift. So I would do that, and then I would note what I'm given. It says two lifts that add up to 750 pounds, and then it gives me a relationship between the amount of weight in the two lifts. If you're struggling with translating English into math, you may have heard me make the recommendation in the past to insert a step between reading and making equations, where I recommend writing something I call half math, half English. If you want to try that out here, that might look something like writing down literally the words two lifts and then an equal sign and then 750. So that's not like an equation that you're going to solve, but it's also not just pure words, if that makes sense. Kind of like half words, half math. And then I also might write something like 2x first equals 300 plus second, something like that. Again, just kind of capturing the basic logic of the problem rather than forcing myself to try to get to like a flawless, perfect, grand equation that I can then simplify on the first step. There's nothing wrong with that if that comes naturally for you. In fact, it's awesome. And like if that is you, a lot of us are jealous of that. But for most of us, and myself definitely included, a lot of times it's really, really helpful to do that intermediate step. And it just helps wrap our mind around the question, avoid mistakes, and set up more intelligent equations. So it might not seem helpful on the surface. It might even seem like a waste of time. And I guess if you're that person who never struggles with these kinds of translations, then it probably isn't a good move. But if you do struggle, this is surprisingly helpful in most situations. And I very much encourage you to at least try it out and judge it based on the results that it gets you. Either way, at this point, we'd start setting up some actual equations for the relationships. I would probably create a variable also for the second lift, since that's clearly important, and I would just write down S equals second lift. If the two lifts total 750 pounds, then I can create an equation that says F plus S equals 750. And then for the other relationship, I can create an equation that says 2 times F equals S plus 300. If you struggle to translate equations, we've got a bunch of word problem lessons in this math real GMAT problem series. And if you just search in the feed word problems, translations, that kind of stuff, then you'll get some hits and you can hear me go through like quite a few more problems that are very translation focused. I'm not going to go super deep on the technical aspects of that in this lesson because I've covered it so much in the past. And also we've got a whole math basics series on like algebra and fractions and percents. I'll bring those up later as we touch on those concepts throughout today's lesson. But I just want you to know all that's there for you if you do want to hear me go a little bit more in depth in terms of how I'm translating this and how I'm thinking about setting up these equations. Now that we have those two expressions, F plus S equals 750 and 2F equals S plus 300, we've got enough information to solve for the first lift using algebra. So speaking of that math basics series, we've got the equations episode linked below, and we've also got an episode on solving multiple equations at one time, which is called a system of equations. If you're feeling rusty on that or you just want to check your skills, that's a great place to go. Again, those should be linked in the description here. At this point, most folks are going to default to substitution, and that's an incredibly useful tool, and it's worth being super, super familiar with substitution. You'll end up using it quite a bit probably on test day. But I have noticed that frequently on the GMAT, elimination is a little bit faster and a little bit easier for certain types of folks and certain types of problems. So I'm going to demonstrate that here. And again, there's more on this in the math basics episode I just mentioned. To use elimination well, and again, I go super in depth on it in that basics episode. So I'm going to just talk about the high level points here. You'll generally want to stack the equations one above the other on your scrap paper and line up each variable, each in like its own little column. So to do that here, I would subtract S, the variable S that I made to represent the second lift, from both sides of the equation. 2F equals S plus 300. So you'll notice in the first equation, F plus S equals 750, the F and the S are on the left side of the equation. So that's kind of the philosophy I'm using for the second equation, is put F and S on the left side of the equal sign. So subtracting S from both sides. But we could have reversed it and done it to the first equation, and I go quite in depth with that in that basics episode, like I was saying. So this is the move I would probably make here. So I'd have F plus S equals 750, and then right under that, I would write 2F under the F. I would write minus S under the plus S, and then I would write equals under equals, and then I would write 300 under 750, almost like I was going to do long addition on the equations. And at that point, if I add those two equations together, you might be able to see that the s variable is going to disappear. And that's really good news because that's going to allow me to solve for f, which is what I want. Now, it can take a little while to get used to that approach. It's definitely not for everyone, so there's no need to force it if you're having the success that you want to see with substitution. And substitution, I believe, works 100% of the time that elimination would. But I do think that you'll find having that trick up your sleeve can be super, super helpful in quite a few situations, like surprisingly more than I would expect. That's been my observation. So that's why I wanted to just touch on that here. So if we sum those, we've got f plus s and 2f minus s. We add that up. That just gets us 3s because positive s plus negative s is 0. That cancels out. So we just get 3f on the left side of the equal sign. And on the right side, we add 750 and 300, which gets us 1050, 1050. So our new equation is 3 times f equals 1050, and then we can just divide both sides by 3 to get f is equal to 350. And it's totally fine to do long division there. I'm just glossing over it because I've done so much long division live on this pod, and I think at this time, most points worth making about that have probably been sufficiently made. But definitely correct me if I'm wrong. If you like listening to me do long division, I guess it's immortalized there in those past episodes for you. You're welcome to go back and listen to those. But if by popular demand you want me to do it every time, then I am open to that, and I'll give you a way to get in touch with us a little bit later if that is indeed the case. But I have a sneaking suspicion that I am right that glossing over it is okay at this point. So that gets us our correct answer of D, as in delta. And that's pretty much that. I don't think there's too many big pitfalls on this question. It looks like based on the miss rate and the make rate, some people might just be making math or algebra or setup mistakes, like translating the problem wrong or like doing some wrong math. But I think all the advice I gave here about writing what's given and asked, labeling variables well, and using elimination is going to head off most, if not all of those pitfalls. So I think that's probably good for our warm-up problem today. As usual, I recommend pausing and making a note to self if there's something that you want to remember from that question. And when you're ready, let's dive into some potentially trickier questions. All right, again, pause if you want to make that note, and then let's jump into problem 138. The problem says, at a loading dock, each worker on the night crew loaded 3/4 as many boxes as each worker on the day crew. If the night crew has 4/5 as many workers as the day crew, what fraction of all the boxes loaded by the two crews did the day crew load? I'll read that again. At a loading dock, each worker on the night crew loaded 3/4 as many boxes as each worker on the day crew. If the night crew has 4/5 as many workers as the day crew, what fraction of all the boxes loaded by the two crews did the day crew load? All right, go ahead and pause. Try that one out. I think this is a really good follow-up problem to the first one because we can use a lot of what we just discussed to make this one easier. What's interesting here, though, is that while only 10% of us missed the previous question, which arguably is like too much, but also not like a crazy number to be missing, 23% of us missed this one. So it's more than double the miss rate. And a large portion of us are going for option C, as in Charlie, which unfortunately isn't correct. And I just realized I didn't read the answers, so I definitely am cheating now. Oh, I'm sorry, everybody. I guess it was bound to happen after how many? 32 of these, and what? We're up to problem 96 or 100 or something at this point. So hopefully that's the first and last time I'll forget to read the answers to you. But let's forget that I just mentioned that about any of the answers, and let me read those to you. Option A is 1/2. Option B is 2 over 5. Option C is 3 over 5. Option D is 4 over 5. And option E is 5 over 8. So my apologies. Please feel free to try the problem again. And I'm sorry I might have spoiled that by saying option C is not right. But it's a very, very popular option. Lots and lots and lots of us are going for C as in Charlie, which, I think it just warrants a discussion. Let's talk about a couple techniques you can use to avoid that pitfall and just make this question and others like it as easy as possible. So, hate to sound repetitive here, but I recommend starting by writing what's given and what's asked. So, we want to know the fraction of all the boxes that the day crew loaded. And when I'm asked for a fraction like that, I like to make sure I write it as a fraction right at the beginning of the problem. So I know how and where to plug in values once I get them. Now, it could be a half math, half English thing if you want to. And I recommend that all the time. I do that myself all the time. There's something about it, I think, that just having that fraction visualized from the beginning of the problem really cuts down on the number of misses. But it is optional. And again, I've said this so much, but if you're getting great results, like, don't change. Keep doing what you're doing. But just by the numbers, that tip alone, just writing the fraction at the very beginning of the question and framing what it's being asked as a fraction, technically increases the odds of success here by 13%. That's the number of us who pick C incorrectly. So it definitely seems worth it. And if you did end up going for C, like, better that it happens in practice than on the real exam. Every question you miss in practice is something you probably will not get wrong on test A if you make those notes to self and you continue to practice consistently. So that's why I'm always pushing all that stuff. Just want you to be successful and avoid the pain and suffering that I went through and that so many folks go through every single year here. It's just totally unneeded. And if all we need is this pod to help, then let's do it. So to create the fraction that I'm talking about here that can help, you can use the half math, half English approach, like I said, and you can just write day crew over total or something like that. Or you could write day crew over day crew plus night crew. Or more specifically, you could write day crew boxes over day boxes plus night boxes, or day boxes over total boxes. Like, I recommend experimenting and seeing what works for you. And I think you'll like it. I think it'll help. As comically simple as that might sound. So you can also define variables, and you can use those to represent the fraction we're asked for. Both ways work great. And after we've got that, we're going to want to organize what's given. And that's a little bit more complicated in this one than the first question. So I think some of the miss rate is coming from the complexity, but some of the miss rate is probably coming from just not having really excellent habits. So in situations like this, when you've got a lot of items to keep track of, I recommend trying to use some rows and columns. Rows and columns tend to work really well as visual organization tools, so it's often a good idea to use them on word problems. And the way that might look on this question is I might make a column header for day crew, and then I'd make a column header for night crew, something like that. You could also make those the rows, obviously, but I don't know, just shooting from the hip, that's probably what I'd do. Day crew and night crew, like right next to each other as the top of two columns. And then I'd do some rows for the different items that we're told about for each crew. For example, we're told about boxes per worker at the beginning of the problem. So I might make that a row. I'd just write boxes per worker. And then under the day crew column, I would write D. I'd create a variable there to represent the number of boxes each worker on the day crew loads. And then in the same row, under the night crew column, I'd probably write something like 3/4 D, because the question says each worker on the night crew loads 3/4 as many boxes as each worker on the day crew. So that's a nice way to keep everything labeled, to keep everything organized. It doesn't have to be like perfect rows and columns, but I think you'll find like even just okay rows and columns make like a tremendous positive difference in situations like this. So we're also told about the number of workers, so I'd probably make a row for that as well. So I would do under the first row I just made, just to try to be as clear as possible, I would write workers, and then under the day crew column, I might make another variable since I don't have any of these quantities given to me. I'd write W to represent the number of workers on the day crew. And then the same row to the right, under the night crew column, I could write 4 over 5W to represent that relationship. And now I've got a really nice organized table where I can clearly see what represents what, which is a very similar upside to writing out what each variable represents in a simpler problem. So when you have like lots and lots of variables to keep track of, it might be easier to do the rows and columns thing versus on the question like the previous one, maybe you just write, D equals day worker rate or something, like whatever the case may be. I also like that I can often see the mathematical relationships a little bit easier with the rows and columns thing. So in this case, it's nice that I can actually see the total boxes that each crew is going to load. I can see a little bit more easily that I multiply the boxes per worker times the number of workers, and that gets me total boxes. And I want that because that's what the question's asking for. It's asking for the day crew over the total boxes loaded by all crews. So I can even make a row for that. Under the first two rows, I could just write total, and then under day crew, I could do D times W because that's D boxes per worker times W workers. And I think it would be that simple. Similarly, with the night crew, I can see that 3 over 4 D boxes per worker times 4 over 5 W workers is going to equal the total boxes that the night crew does. So if I did 3/4 times 4/5, I would just get 3/5. So the total boxes that the night crew loads is 3/5 times D times W. Now, please check out that fraction math basics episode linked below if you're not rock solid on your fraction multiplication or like why 3/4 times 4/5 is 3/5. Okay, and we all started somewhere. I had to do a ton of foundational math basics work, even though I like studied a ton of math in college and like would, studied engineering in undergrad. Like a lot of that stuff had just floated away from all the Excel and AutoCADs and calculators. And, these days, who even knows what the youths are using out there? um, but the point remains there's no calculator on the GMAT quant section. So if you're just starting out, that's good to know. And so just getting more solid reskilling, if you will, with hand computation of fractions is quite valuable. And pretty much everybody went through it. So no stress there. Just, knock it out. This is like a project at work. You get it done, you level up, and you're on to the good stuff. So now I've got enough information to solve for what's asked if I have that total boxes row filled out. And I guess I don't want to make it sound easier than it is. A lot of people really struggle to see those kinds of relationships. But that's my whole point with doing the rows and columns thing. Getting used to organizing information from word problems in rows and columns should help make those questions way, way easier. It should make it easier to see those kinds of connections. Maybe we can't make it easy, but we can almost certainly make it easier. And that's our goal here. So let's assume we get to that point. It's important to say that we are not done with the problem, but I do want to circle back to why a lot of us are probably picking C at that point. Recall that C is 3 over 5, and that represents the fraction of the boxes that the night crew loaded. That's a really, really easy mix-up to make. A lot of people are just doing, oh, cool, I've got, 3/4 times 4/5, that's 3/5. About 13% of us, like I said, are doing that. And we don't want that to happen. And if you have everything labeled in your rows and columns or labeled clearly in a way that you prefer, you're just way, way, way less likely to make that mistake. And same thing with writing the fraction, the question as a fraction at the beginning of the problem. So let's make the last couple steps clear on this one. So we're being asked for the fraction of the boxes that the day crew loads, and to figure that out, we just put the total boxes loaded by the day crew, which I wrote as D times W, over the total boxes loaded by both crews, which is D times W for the day crew plus 3/5 D times W for the night crew. Then we can add the quantities in the denominator. That would get us 8 over 5 times D times W. Again, please check out that fraction basics episode if you're not sure how that happens. And then we would have D times W on the top of the fraction and then 8/5 DW on the bottom of the fraction. From there, we can cancel the D times W in the top and bottom. That gets us 1 over 8/5, and that just becomes 5 over 8. And that gets us to our correct answer, which is option E, as in echo. So it's definitely not an easy problem. 23% of us end up missing this one, but It's probably more of an organizational challenge than it is a mathematical challenge. That would be my guess. Like if you think about how advanced the math itself is in that problem, it's basically just fractions. And that's why I was hitting on that whole math basics episode and why it's so important. But once you get that, or if you never lost it, then it's not like there's some crazy math going on in that particular question. But organizationally, apparently it's tough. Almost a quarter of us are dropping that one. And I don't think it needs to be that way. So it's worth noting that a lot of people like replacing variables with numbers on this question. And I think that's an awesome approach. It really works well. But part of the reason I went through the algebra approach here is no matter which one you take, I highly recommend having that good labeling system just in case just in case. I mean, it's just so easy. It's so terrifyingly easy to get mixed up on these questions and get them wrong. And that's true, I think, whether you're dealing with variables or numbers. So the plugging in numbers approach, super popular, super helpful. A lot of people really like it, but it's sometimes like so useful that it can make it seem like you don't need those labeling habits that I was talking about. And again, if you're that person who's getting them all right and you're already hitting the goal score, like great. But if that's not you, then yeah, just a little bit of labeling goes a long way. So hope that helps. Again, please pause and make a note to self if there's something you want to recall from that problem in the future. And then let's round out our lesson with one that appears to be just a touch more difficult. This is problem number 142. The problem says, of the 3,600 employees of company X, 1/3 are clerical. If the clerical staff were to be reduced by 1/3, what percent of the total number of the remaining employees would then be clerical? I'll read that again. Of the 3,600 employees of company X, 1/3 are clerical. If the clerical staff were to be reduced by 1/3, what percent of the total number of the remaining employees would then be clerical? Option A is 25%. Option B is 22.2%. Option C is 20%. Option D is 12.5%. Option E is 11.1%. Again, recommend pausing and getting as far as this one as you can on your own. Pretty interesting problem, I think, because even more of us missed this one than the previous question. But again, most of the correct answers are concentrated on just one of those choices. So let's make sure all of us have the right approach and can avoid that trap. So another time, I'll repeat this. Let's start with what's given and asked. We know what fraction of the total workers are clerical, and we have the number of workers. We're told to reduce both quantities, and that should allow us to calculate the desired percentage. And I think on this one, it's totally okay to use some equations, but I would probably just take the step-by-step approach. I was talking about this one, I believe, in the previous episode of this series, so worth checking that out if you want a little more commentary on this step-by-step approach. But it's there's not much to it. I'm just going through the problem, doing one calculation at a time. So let's start by figuring out how many workers are clerical. There, I would just do 1/3 times 3,600 over 1, and that's 1,200, 1,200. So that lets us know we've got 1,200 clerical workers. Now we want to reduce that by 1/3. So again, I'm just kind of going one step at a time in the problem. So just be careful here, because reducing something by 1/3 is not the same thing as taking 1/3 of it. 1/3 of something is 1/3 times the thing. So for example, 1/3 of 15 is 5. But reducing something by 1/3 means taking 1/3 away from it. So reducing 15 by 1/3 means we take away 5, and reducing 15 by 1/3 yields 10. So very, very different results, 1/3 of versus reduced by 1/3. Different things. Just easy to get mixed up on that. Wanted to drive that home in case it wasn't clear. So if we want to reduce 1200 by 1/3, we take a third of it, and then we subtract that from 1200. So 1/3 of 1200 is 400. Let's subtract 400 from 1200. That gets us 800 clerical workers if we were to reduce the original number of clerical workers by 1/3. We now know there would be 800 clerical workers, and it looks like the vast majority of us figure that piece out, which is kind of interesting based on the missed distribution. But the problem seems to be that at that point, many of us compare that 800 to the original 3,600 workers, and we calculate that as a percent. And unfortunately, that's not right. 8 over 3,600 would get you 22.2%, which is B as in beta. And it looks like about 20% of us are doing that, which is a lot. That's a big, big segment. It's a super understandable mistake, but of course, we do not want to be missing questions like that, especially not for that reason. So why is B not right? The key word there is remaining employees in the problem. So we're asked what percent of the total number of remaining employees, and that means we need to reduce the 3,600 number by 400 as well. We can't just reduce the clerical workers and leave the total the same. We're like letting go of 400 of those people, so that's reducing the clerical workers and also reducing the total workers. That can be a little bit tricky. It also can be tricky because you might be thinking we need to reduce 3,600 by a third, but that's not exactly true. We're just reducing the clerical staff by a third. So we just need to remove the 400 from the 1,200 and the 3,600. And if we do that, we would have 800 clerical workers over 3,200 remaining workers. Again, that's the key phrase. And 800 over 3,200, if you reduce, is 1/4, which is the same as 25%. That gets us to our correct answer, which is option A, as in alpha. Okay, so what's the key there? There could be a few techniques that could help, but I think the most valuable one is probably rereading the question wording before you finalize your answer. You can also reread the question wording after you set it up. You can also do both. I think it just depends on how often you're making these kinds of mistakes. We've talked a lot about double checking things in the quant section in this series, and for good reason. Failing to double check can cost serious points in this particular game. And if you play that out over the next, 10, 20, 30 years of our careers, that really adds up. So it's generally worth it. And I encourage you to experiment with double checking every step of every math problem so that you can figure out which places the double checking adds the most value for you. And I think that's how you can figure out what your optimal approach is. But if you're the type of person who doesn't want to run that experiment and you just want someone to tell you like, hey, when should I double check stuff? It's a great idea to double check the question, like just reread the question that you're being asked in the math problem right before you submit your answer. That's a great way to double check and make sure you haven't missed anything big. Having said all that, the techniques that we spoke about today, every single one of them will help with this problem as well, and they will reduce the error rate for sure, as they generally do with most word problems and most quant problems in general. So wanted to keep that one lean, but still stay focused on the stuff that I think is going to have the most impact and the stuff that apparently causes the most misses on these questions, which, as I've said so much, checking the stats, it's a little surprising how often we all miss things, and yet it's unequivocally true. And so we might as well just meet it head on, like confront the brutal facts, the reality, as it were. So really hope you got value out of today's session. If you have any questions about anything we've discussed here or anything else related to GMAT or your GMAT prep, feel free to reach us via DM at the GMAT Strategy on current social channels, or you can email us. Our email address is contact, CONTACT, at thegmatstrategy.com. And we love hearing from you, and we're happy to help as much as we can. Sometimes we do get a little backed up, like at this time of the year, September, October, November, December, where we got the big deadlines and big rounds. Sometimes we're a little slower to respond. But again, we still like hearing from you. We still like to help. So please don't be shy if you have questions. I guess on that note, if you're struggling with your prep and you're not progressing as fast as you want to, or you're not seeing results with your current approach or your current provider, like if you're seeing score drops or your score is stagnating, I do just want to mention that we offer a free service to help with those situations specifically, since that was a situation I was in back in the day, and there really was like no help in that situation. I had to figure it all out for myself, which was like really difficult and time intensive and painful. I struggled to an extreme degree with the exam, despite being what I think most people would consider a great student for my entire academic career up until that point. It was definitely not an effort problem, I will tell you that. It was just an insane number of hours every single week on top of my job. And I was going nowhere fast. My score was going down every time I took a practice test, and it was super challenging. It was very unexpected, and I don't want that to happen to you. I don't want you to have to endure that if you don't want to. So if you want, you can head to our website and you can book a call to speak with us live. We'll ask you to share a bit about your situation, and then we'll help you figure out how to move forward more efficiently. There's no charge for the call. There's no obligation for the call. We don't favor any particular vendors when we make recommendations. We just recommend what we think is going to be best for you based on our extensive knowledge of the industry and the exam and all the options that are out there. And it's there for you to be able to get personalized advice no matter what situation you're in. Additionally, if you are interested in working with us directly, we do offer programs on a limited basis. If you want to learn more about those, please just ask when you're on the call and we're happy to share. But it's not a situation where that's required or even expected. The call is really just there to help you if you're struggling. If you want to learn a bit more about our approach beforehand, just head to our website and check out our free video on how you can reach your dream GMAT score in half the normal time. And from there, you'll be able to book your call if everything's resonating. And if not, that's totally cool. If none of that sounds good to you, no stress. We will be back soon to keep supporting your success right here. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. You can do it. Talk to you soon.